testing.
Yo. Sorry about that. So I was saying that some of you might wonder what is this presentation going to be about. So I'm going to start by explaining what does it mean doing real-time analytics at scale. So what does it mean doing analytics at scale? So for me, doing analytics is mostly about getting some insights, mostly about learning something that is not obvious from your data set. If you take the example of the ad tech industry, imagine you have like a bunch of servers that are displaying your ads, and every time they serve one of your ads, they essentially log an event with a bunch of information related to the ad that you just served. So this kind of event could look like that. Now if I ask you to give me some insight about this event, you could probably tell me, okay, one of my ads has been viewed on NewYorkTimes.com by someone using an iPhone. This someone was located in Santa Maria, California, and his internet service provider was Verizon. So I would say, good job, you have been doing analytics because you are essentially able to understand your data sets of one event in this case. Now let's say I give you billions of these events a day and I ask you the same question. You couldn't tell me that much about it because the scale is essentially too large, right? So doing analytics at scale is, being able to answer questions like how many people in my network are using an iPhone, how many of my ads are viewed in NewYorkTimes.com, and be able to answer these kind of questions even if you have to deal with a really large amount of data, essentially. So now, what does mean real-time in this context of analytics? So when you talk about real-time analytics, there are essentially two main components. The first one is about response time. Like, how long do you have to wait every time you query your system to get an answer back? Is it seconds, is it minutes, hours, or even days? Obviously, when you talk about real time, you kind of have to put a definition about it, behind it, sorry. So you could have a different definition than mine, depends on the companies, depends on the use cases. At GumGum, we say that we are doing real time in terms of response time for our system, when we can achieve an average response time at around 1 second in our system, because we know the people we are working with and we know they're happy about that, and we still feel like it's very fast and we give them a nice user experience when they are exploring our data. So when you talk about real-time analytics, you also talk about data freshness, like how fresh is the data you can query on your system. What is the amount of time for an event to occur until it gets reflected in an answer in your system. So once again, you can have different definitions about real-time here. At GumGum, we say we're doing real-time in terms of data freshness when we can achieve an average latency ingestion of our events at around 30 seconds. Because once again, we know our people, we know that they're happy about it, and they still feel that the data is frequently updated, and they still feel like it's essentially understanding what's happening right now in our business. So a little bit about me. My name is Guillaume. I'm French. I had my first experience in big data when I was working in Paris for a company called Hbase. I was doing image recognition in this company. So there was a lot of machine learning involved in this position, but not enough data to play with. So I decided to quit, and I joined GumGum 1.5 years ago. I've been involved in the Druid projects since the very beginning at GumGum, so I have about 1 year of experience now with Druid. Bit about GumGum. So we are an ad tech company. We have invented what we call in-image advertising to 2008, which is a concept of overlaying ads on top of images. So we have image recognition technologies. We are able to detect objects inside images, and according to what we can detect, we serve relevant ads on top of these images. So we have a very high viewability because people usually, when they browse websites, they focus first on images, so they see our images, ads first. In terms of number, we are processing 2.6 billion images a month. We're doing 10 million impressions a month, but we're actually producing 10 million events a day. We are working with 2,000 premier publishers and top advertisers like Coca-Cola, Cadillac, Disney. We are 132 right now. We are growing a lot. It's like a 40% year-over-year growth. We are growing a lot in terms of number of employees, but also we are seeing a huge increase in our data volume. So the people who are working at GumGum, they need to get some insights about the data we're producing. So in order to give them access to this information, we have built a reporting platform that we call the dashboard. And here's the kind of report you could find in this platform. So it's pretty classic. You have graph, you have tables with a lot of data. You can filter by a bunch of dimensions. You can see metrics related to the ad tech industry, number of impressions, number of clicks, and so on. In this case, we have broken down our report by two dimensions, which are the advertisers and the ad campaigns we're running right now. So this kind of report is really important for our people, especially our AdOps team. They are constantly watching those numbers in order to understand and monitor the ad campaigns we are running and see if they're going to meet the requirement we have solved. So what do we need to provide to our people? We need to give them interactive data exploration, meaning that we need to provide them with different views of our data. They need to be able to refine their query along the way until they get the answer they are looking for. We need to give them fast results. They don't want to wait minutes every time they refine their query. And we need to give them access to fresh data. So one use case we could have for accessing fresh data is, again, our AdOps team, they set up some campaigns through the dashboard, and then at some point they enable those campaigns, and they want to see in real time if we are actually starting to serve ads, if we're targeting the right websites, if we're serving ads at the proper rate, and so on. So being able to access real-time data is really a big requirement at GumGum. So before we met big data, we were essentially using MySQL for real-time reporting. So what we're doing is we're sending our events to Kafka, then we're consuming those events with Storm. We were aggregating those events, and at some point when we had aggregated enough events, we were essentially doing batch updates of MySQL metrics. So this solution was kind of working for us, but at some point we introduced new domains like RTB for real-time bidding, and these kind of domains had 10x more data than the data volume we were used to deal with. So we figured out MySQL couldn't keep up. We needed to scale horizontally versus vertically, and MySQL wasn't obviously the answer for that. So we started to look at some open source solutions that could solve our analytics problems. And we came across Druid, which is a distributed data store built for analytics. And I have to say that so far we've been pretty happy about it. Brief history about Druid. It's been built by MetaMarket, which is another ad tech company. They sort of had the same requirements as we have, and at the time they were looking at some open source solutions as well, like we did. But they didn't find anything, so they decided to build Druid from the ground. So they open sourced the project in 2012 under GPL, and then in 2015 under the Apache license. Since then, Druid has been adopted by top tech companies like Yahoo, PayPal, Netflix. I think Netflix is using Druid to monitor the entire infrastructure of EC2 instances. So what they do is like they ingest log on the fly, and then they are able to detect in real time like peak of errors and trigger some alerts and stuff like that. So Druid is becoming very popular, and it's not only used by high tech companies, it's also used by other kind of companies like PayPal or Yahoo. So some key features about Druid. So Druid is very good at what we call arbitrary slice and dice on data, meaning that it's good at breaking your data into smaller parts and give you access to different viewpoints on this data. So the idea is really to be able to zoom in and filter your data efficiently. It's meant for fast aggregations on time series data. So first of all, Druid only understands time series data. You even needs to be timestamped for Druid to understand them. And you need to give them dimensions and metrics, because Druid only deals with dimensions and metrics. So it's really good actually at aggregating your metrics over your set of dimensions, essentially. It's highly available, meaning that there is no single point of failure. It's production ready, you can use it, and you shouldn't experience any downtime. You should always be able to query your data. And it's distributed, so it scales linearly. You can easily add more nodes if you want to handle your data volume growth. So I'm going to make a quick demonstration of what you can do with Druid. I'm going to just explore like the data we have in our Druid cluster at GumGum. And in order to do that, I'm going to use a new AI analytics called Pivot. So this is a web app. This is a web app. So you just have to install this web app. You give it access to your Druid cluster, and then it's going to scan your cluster and give you access to nice reports for you to analyze your data, whatever data you have in your cluster. So here is like all the data sources we have at GumGum. You can see a data source as a table in a relational database, the same concept. Let's go over this data source image impressions by URL. So this is a pretty simple data source where we are tracking essentially our inventory image impressions over some dimensions. So let's say I want to know my top domains for today, meaning that the website domain where I've been doing the higher number of impressions. So I can just quickly split my data by domain and then sort by impressions. And then I can see, okay, my top domain today was dos.com and then runchic.com and so on. So now maybe I want to know what were my top domain by country. So I can split my data by country, subsplit by domain, and then I can quickly see that in the US, okay, dos.com, runchic.com. In Canada, it was dos.com as well, but it was different for the second one. So yeah, it's pretty easy to explore your data, and it's pretty fast to query, as you can see. So now, let's say I have a campaign where I want to target like French people. So I want to target only French-speaking countries. So I can filter my data. Let's see, France, Belgium. Switzerland. So here quickly I can know, okay, maybe I want to target those websites because I know that I have the most inventory image impression on those websites. So it might be good for my campaign to run against these websites. So this is a pretty simple data source. We have other ones where we track way more dimensions and way more metrics, like for example this one. You might want to, for example, for some of your metrics, you might want to see the evolution over time, for example. So you can split your data by hour if you want, and let's say for past week, and you can visualize like the evolutions of your metrics really easily. It's kind of hard to see right now because on this data source we have only up to 1 hour time granularity available. But the data, the data points you are seeing here are real time. We're actually right now ingesting data in real time. Let me see if I can. Let's go back to this data source. Let's grow it today, and let's do 1 minute granularity so that I can show you. So here it's 3:57, so it's UTC time, so it corresponds to now, right now. So I have 3.2 thousand impressions. If I update, the data gets updated, I have now, 13,000 impressions. So as you can see, it's user-friendly, it's fast to query, and you can get really quickly insights about your data. Let's go back to the presentation. And take a look at the overall architecture of a Druid cluster. Like what are the pieces in a Druid cluster and how they work together essentially. So a Druid cluster is a set of different type of nodes, and each type of node is designed to do a specific set of things very well. So, and all of these type of nodes essentially operate together to form a fully working system that's able to solve your analytics problems. So everything starts with some queries. Your queries first eat your broker nodes, which are essentially, those nodes are query routers to two other kind of nodes, the real-time and the historical nodes. So the real-time nodes, they deal with the streams of data. So what they do is they ingest your streams of data and aggregate your data and make this data immediately queryable. So at the very high level, they essentially, your events eat these nodes, and then they get aggregated, and at some point your node flush your aggregated events out of memory, and they transform the events they have aggregated into an immutable internal representation of your data, and then they take this representation and hand it off to some other node which are more specialized in dealing with immutable data, which are the historical nodes. So the historical nodes, essentially, they load data from this deep storage, and they respond to queries. So they are the main worker in a Druid cluster because they hold most of your data, your historical data. So the deep storage here is the layer in Druid that ensure you that you're not going to lose your data. So you can use a bunch of solutions. You can use S3, you can use HDFS or even Cassandra. So if I have to sum up, so your queries eat your broker nodes, your brokers forward your queries to the right workers, your query gets computed in parallel over your workers, and then your workers give back their results to your broker. Your broker merge those results and give a final answer back to the client. Druid has the concept of data balance and replication. So Druid chunks your data into what we call Druid segments, which is a data unit in Druid. And each Druid segment is associated to a time interval and a segment metadata. All your segments metadata are stored in the metadata storage, which is MySQL in Druid. And there is another kind of node, type of node, which is a coordinator, and the coordinator understands essentially your segment metadata, and it understands what data should exist in your cluster. So every time it runs, it queries MySQL, figure out what data should exist in your cluster, and then tells your historical node to load new segments, drop outdated segments, or move segments from one node to another for load balance. It's also responsible of replication. So if you want to replicate your segments, you can do it. It's obviously good for availability, because if you lose one of your nodes, it's not a big deal. You can always find your segments on your other nodes, and your data is still queryable, essentially. So if you want to replicate your segments, once again, you just have to configure that on the coordinator console, and it will take care of that for you. What about data ingestion? Like, how do you put data into your system? So you have two ways to do that. First way, you can obviously use the real-time ingestion capabilities of your real-time nodes. You can plug these nodes directly to some pub message system, such as Kafka or RabbitMQ. If you need an ETL layer in between, if you don't have your data ready in your Kafka cluster, if you need to extract dimensions and metrics, you can use Storm in between, process your data, and then push this data directly to your real-time nodes. You can obviously use batch ingestion as well. So you can use the Hadoop Druid indexer that comes with the Druid project, which is essentially a mapper's job, which takes your data as an input, creates segments out of your data, Druid segments, and then update MySQL Druid to notice Druid that it has to load these new batch segments you have created. And then if it's needed, the coordinator will essentially replace your real-time segments by your batch segments. So now that you understand more or less what a Druid cluster looks like, we can try to explain why Druid is fast to query. So Druid is fundamentally a columnar data store, so it stores your data in column. So for those who are familiar with columnar data stores, you will understand that that's one of the main reasons why it's good and fast at aggregating your matrix over your set of specific dimensions. If you take a look at this data set here, you have two dimensions, product vertical, and some matrix here. So let's say you want to aggregate your matrix over one specific dimensions, which is vertical here. Druid is gonna obviously only scan this column and will skip right away the product dimension here. They also use column compression with dictionary encoding. So the dimensions values you are seeing here, gaming fashion, they are not stored in their string representation in Druid. Druid is actually creating some internal IDs. So in this example, gaming gets transformed to 0 and fashion gets transformed to 1. And then Druid takes those internal IDs and creates an array that represents your column or your data. And this representation you can see here is pretty easily compressed. So it's easy to see that the more you can compress your data, the faster you're going to be able to query it and to scan it, essentially. Druid also built an index that's helping him to really narrow down the data it has to scan every time you apply a filter on your query, on your queries. So if you take a look at this data set again, for each value of your dimension, Druid is gonna create a byte array essentially that indicates which row a certain value was seen. 1 meaning that your value was seen, 0 meaning that it wasn't. So if you take gaming value here, Druid will create this index and will happen 1 and 1 at the beginning because gaming was seen in the first 2 rows, and 0, 0 at the end because it wasn't seen in the last 2 rows. So now, imagine you want to issue a query that focuses on gaming, for example. Druid will only scan the first 2 rows right away. Now imagine you want to issue a query that focuses on gaming or fashion. You can take those 2 representations, those 2 indexes, order them together, and quickly figure out that you have to scan your entire data set in this case. So they also compress these indexes actually. They use an algorithm called consist compression. And the beauty is that they can actually perform Boolean operations on the compressed form of the indexes. You don't have to decompress the data. So at the end you use less memory and you get a faster scan rate essentially. So if you are more interested in this consist compression algorithm, you can go to their website, Druid.io. They have posted about it. It's pretty interesting, so maybe we should check it out. So those are the main reasons why Druid is fast to query, but it doesn't explain why it allows you to query real-time fresh data. How does it achieve essentially low latency ingestion for your events? So if you want to understand that, you sort of have to zoom in what's really happening in your real-time nodes. Because those are the nodes who are ingesting your data in real time. So in the real-time ingestion process, there are essentially 2 main components, a write-optimized component and the read-optimized component. So first, your events goes into this write-optimized component. Behind the scene, Druid uses like a gigantic hash map where the keys are a hash of the time dimensions and all the other dimensions you will have in your segment. And every time an event goes here, there is a lookup that's done by Druid on this hash table to see if there is one entry your event can roll up into. And if not, Druid only just happen your event to this hash table. So this aggregation process is very fast because hash table is one of the fastest data structure you can write to. So this process is fast and gives you fast aggregation, but your events actually don't stay that long in this component. Your events actually get flushed out of heap and persisted into a Druid segments, which is really read optimized. So during your real-time ingestion process, Druid is gonna, persist your events X times, depends, and create a bunch of segments, Druid segments. And then at some point it will merge these segments into a final segments and then lead off to some nodes, historical nodes, which again are more specialized in dealing with immutable data. So the key here is that Druid can achieve fast aggregation here, but because it has to query this data as well really fast, your data gets flushed out of heap and persisted into a read-optimized data structure, periodically essentially. Druid at GumGum, how do we leverage Druid capabilities at GumGum? So here is a diagram of our current architecture. So we have 2 pipelines. real-time and batch pipeline. For the real-time pipeline, our ad servers essentially send events to different Kafka topics. We are consuming these events with Storm. We are processing those events, we are extracting dimensions and metrics, and then we are pushing those dimensions and metrics to Druid for real-time ingestion. We have also a batch pipeline, so our ad servers send our events to Fluentd. Fluentd buffer those events, create files, and store these files to S3. And then every hour, we trigger a MapReduce job that takes those files, process them, extract again dimensions and metrics. And then we use the hadoop Druid indexer to create segments out of this processed data. We update MySQL Druid, and our real-time segments gets replaced by our batch segments automatically. So this kind of architecture is pretty common in the big data industry. It's called the Lambda architecture. If you're wondering why we have to maintain two pipelines, it's because of the states essentially of the streaming processing technologies. They don't ensure you that you can process your events only once. Your events in your real-time pipeline might be over-delivered. You can miss some events. So if you want to correct those failures, you essentially need to replace your real-time data by your batch data. We are not exposing our Druid cluster directly to our clients. We have a reporting server API in between, which is a REST API. And among other things, what it does, it's joining the data we have in MySQL with the data we have in Druid. So in MySQL, we store like dimensions table, like the list of our publishers, the list of our advertisers, and so on. And in Druid, we are only ingesting IDs, like publisher IDs, advertiser IDs. So if we want to map some informations on these IDs, we have to essentially join in memory the data we have in MySQL with the data we have in Druid. And the reporting server is doing that for us. Physical architecture of our Druid cluster at GumGum. So we have two brokers, M4X large with 4 CPUs and 16 GB of RAMs. So you kind of need you need computational power for your broker because they are not only query routers, they also mirror the results they get back from your workers. You want memory if you cache your queries. We don't do that at GumGum, so maybe we could use like C4 X large or something like that with the same amount of CPUs but less memories because we are not using that much right now. We have a round robin between our clients and our brokers, which are essentially distributing evenly our queries to our two brokers. We are using 17 C4 for X large for our real-time nodes. So 16 CPUs and 30 gigs of RAM. We needed a lot of computational power here because the aggregation process is really CPU intensive, and at the same time you need to be able to query this data very fast. So this work is CPU intensive. That's why we have 16 core per machine. We don't need that much memory because we are only holding 1 hour of incoming data in those nodes, in those real-time nodes. So our segments are pretty small and they easily fit in memory. For our coordinator, we are using 2 C3 large. So don't do that much. They only need like 1 core to operate. So I think we could merge them to, like for example, our broker nodes. We don't really need physical machines for our coordinators. That's something we might do in the future. We have 2 nodes for availability. So there is only 1 node working right now. But if it goes down, there is a failover mechanism and the other one will take over and do the work. And finally, for historical nodes, so we have 6 nodes and we have a tiered architecture with 4 hot nodes and 2 cold nodes. So the hot nodes here they're only holding like our most accessed data essentially, which is the new data. And the cold nodes are holding our old data, so the data we are not really accessing that much. And the data we have here are essentially really fast to query because, first of all, because we have more nodes. So the queries that hit these nodes are, more parallelized than the query that goes into these cold nodes. And also the ratio between available memory and disk is way better for the hot nodes. We are using 160 gigs of SSDs, and we have 32 gigs of RAM available. So the ratio is way better than in the cold node where we're using 1 terabyte of SSDs. So this kind of architecture is it's cost effective, and it's really easy to set up with Druid. You just have to flag your node and say what tier you want your node to belong, and then you set up some rules in your coordinator to tell him to load whatever data you want to load in your tier. So some drawbacks about Druid. It's not meant for data updates and deletes because essentially it's only dealing with immutable data. So you can update your segments if you want to, add a new dimension. You can do it, but if you want to do that, you need to essentially recreate your segments. It's kind of complex to set up. There are a lot of type of nodes. You need to really understand Druid and how it works to get the right setup. But I know that Druid people are working right now to improve the setup of a Druid cluster, and they're also working to give you more operational data on your cluster. So SQL is not supported yet for Druid. You cannot query it with SQL. And if you have use cases like us where you have some people who are not engineers but no SQL, you cannot just give them access to your cluster and tell them to query it with SQL. It's not possible. There is a SQL layer which is called PlyQL, which is a SQL-like language to query Druid, but it's not full SQL, so there is no JDBC driver. You cannot plug Druid to SQL Workbench, for example, and start querying it. Some cool stuff. As you have seen, it's giving you fast exploration on a large amount of data. It gives you the ability to analyze your data while it's happening. It's highly available. It's really important for us. You shouldn't experience any downtime and always be able to query your data. And it's backed up by this company, Imply. So this company is building an ecosystem around Druid. They have built, for example, the UI analytics I showed you before, Pivot. They're also developing this SQL layer called PlyQL. And obviously, and in the future, they will, I'm pretty sure, come up with other different projects around Druid. So yeah, that's pretty much what I have. Obviously, we're hiring. So if you want to check out our open positions, you just go to gumgum.com/careers. We have pretty nice open positions right now. If you want to reach me, LinkedIn here, you have some useful links. And if you have, so first of all, thanks for attending. And if you have any questions, please let me know. Here? Yeah. So here, the data you have here is queryable, but it's just it's obviously slower to query. than the data you have already persisted into your segment. But that's one of the key. I mean, here you hold only a really small batch of data that you're aggregating, so it's still fast to query, you know.
So every query is like almost two queries, like one big query over the historical data and then kind of the trickle of the whatever just came in.
Sorry, say that again.
It's like two queries, like one big query that deals with a lot of data, like the historical data, and then potentially like a little bit of trickle from whatever just came in.
Yeah. Like let's say we're like at GumGum, we're only holding 1 hour of incoming data on our real-time nodes. So whoever people is querying 2 days data is gonna eat a small portion of our data here, but then everything is gonna be queried from the historical nodes. Yeah. So Druid is using a windowing concept. So when you specify how to ingest your real-time data, you can specify a window, let's say 10 minutes window. So your real-time node is gonna wait 10 minutes after closing the segment. So if your segment comes after these 10 minutes, then you lose. If your event, comes after these 10 minutes of window, then you lose your event. Yeah, so we are using 1 hour granularity for our segments, and then we have a window of 10 minutes for most of our data. Yeah.
What's the flexibility on dimensions? I know pre-dimensioning is part of it. Like if a new dimension appears or a new possible value appears within dimension, what's the impact on Druid?
You mean if you want to add like a new dimension on your segments?
Well, but 2 cases: the new dimension case as well as potentially a new value within the dimension.
Okay, so for a new value, it's you don't have to do anything. I mean, it's just you query your data and you're gonna see your new value show up in your reports. Then if you want to add a new dimensions on your data source, you can do it, and you don't have to do anything as well. It's kind of schemaless. You can just add this dimension and query your segments. Even segments I don't have and don't know about this dimension, and Druid is gonna figure out and give you the answer you're looking for. So I don't know if does it make sense?
So Druid has the entire, at the very beginning you had a large blob of JSON. Druid has that entire, despite its dictionary coding and all of that, at its heart it actually has that full blob of JSON all the way through.
No, so
if I have a new dimension, like another field in that JSON, that I didn't have a dimension defined on before, I didn't know about it before, I defined it later, do I have to re-ingest all the segments in order for that dimension to exist in Druid's view of my data? Or will it sort of pull that back out of the data that I previously ingested?
So yeah, so the JSON you are seeing is the raw data, right? So log events. So this data you need to process it and extract dimensions and metrics. Then you present this set of dimensions and metrics to Druid for ingestion. So let's say you have 2 dimensions, and then at some point you want to add a new one because, I don't know, you get more value on your log events. You can do it, and Druid will not complain. I mean, it's gonna ingest this data you are presenting and give you, the. So you will not have any insight about your new dimension for your whole data, obviously, but you will get insight for the new data you are ingesting. Yeah, you can do it. So your segments are immutable, so you just have to kind of recreate your segments if you want. Yeah, exactly. Per segment.
So if you think about a time series and didn't have particular values before we're in call, it's not going to be the segment for that point in time.
Yeah.
So I have two questions. So in your slide about the circle node where you have 2 hot nodes and 4 cold nodes, how do you configure which ones are the hot nodes, which ones are the cold nodes?
Okay, so we have actually so 4 hot nodes and 2 cold nodes. So if you want to configure this architecture, you just have to flag. So you just have to flag your nodes and say that, okay, this node in the configuration file, it's a hot node, or you can call it whatever you want. And this node is going to be a cold node. And then, how do you, load the data you want on those nodes? So you just go to your coordinator console and you say, okay, I want you to load only 2 months of worth of data, new data, into my hot nodes, and the rest into my cold nodes. And then the coordinator does it for you. You don't have to care that much about it. It's gonna.
So it's in the coordinator. It's not like in a segment locations configuration.
No.
Okay.
No, this is a node configuration essentially. Sorry.
No, that's
Do you get some data on like what data has actually been accessed and how frequently from the coordinator, or do you have to tell it like I want the last 2 months to be in the hot segment, which I don't know, the last 2 months I've got to use a lot of the last 4. Right?
Yeah, so you sort of need to understand like how you query your system, like what is the most access data you're dealing with. So we know at GameGam that people, they mostly query like 2 months of new data. So we put those 2 months on those nodes, and then the rest on the cold nodes, because we don't really need to be as fast to answer the queries for people.
You look into Hive instead of Druid. Hive is another product.
What's the name?
Hive?
Okay, I'm not familiar with this project. It's the same concept, right?
I think so. I think Hbase is in here. It's one thing a bit different, but this one.
Okay.
KYLI.
KYLI, okay. I will check it out.
LIN.
Okay. Good.
So it's fast query. You also mentioned that you have reporting to
So reporting server is just a REST API. So our people, like the people who are working on the dashboard on the front end, they essentially make call to this web app or REST API, and then this reporting server is in charge of pulling the data from the right place. So if the report requires us to query Druid, then we make the queries from reporting server to Druid. If we need to join data from MySQL, we do it. All the backend logic is there essentially.
How are you connecting Storm to it? Are you using the Tranquility library or is there a
We do use Tranquility. Yeah.
Okay.
You had mentioned your average response time is about a second. What kind of query concurrency are you guys serving?
Right now, we don't have a heavy load on our cluster. I think we have about few hundreds of queries a day, maybe 1,000 or more. Yeah.
So one problem that we're having right now is we're doing a batch just over a minute, and you end up having like a lot of small segments. And we're wondering, we're going to try out is do like an hour batch ingestion on top of that. Will that make the segments bigger? In your experience? Segment files and stuff?
So you are doing 1 minute of 1 minute time guarantee for your batch ingestion.
Yeah, because we don't have the real-time component right now. We're only doing batch.
Oh.
Yeah.
Okay, so I don't know why you guys are doing that, but it's I mean, creating batch segments, you have a lot of overhead, so I guess you don't have really real-time data into your system right now.
We just don't we just don't have it implemented.
Okay.
We wanted to get the batch working first, even if it's like
Okay.
a 5-10 minute delay. So maybe we can expand the window to like 5 or 10 minutes. We're just wondering, when you're expanding the window, making segments bigger. That's kind of the question.
Yeah, so if you ingest, if you have 10 minutes granularity instead of 1, obviously your segment is going to be bigger. Like, it depends actually. If you want to still be able to query your data up to 1 minute granularity, then your segment is going to be bigger, right? Because you have 10 minutes worth of data in the segment with still the same granularity for querying. But now if you say, okay, you want to ingest 10 minutes of data per segment, but you say that your query granularity is 10 minutes as well, then you summarize a lot your data, and maybe the size at the very end of the segment is going to be maybe pretty much the same. I don't know.
Thank you. We're still messing with it. Thank you.
Well, thank you so much.
Thank you.
Sweet stuff.
So let's get started. Thank you guys for coming today. Thanks to Riot for hosting this presentation. So today I'm going to talk about real-time analytics at scale with Druid. That's something we do at GumGum. So some of you might wonder, what does it mean doing analytics at scale? What does it mean doing real-time analytics? So before going further in this presentation, I'm going to explain you these concepts first. So, can you hear me?
What?
Testing. Yo. Sorry about that. So I was saying that some of you might wonder what is this presentation going to be about. So I'm going to start by explaining what does it mean doing real-time analytics at scale. So what does it mean doing analytics at scale? So for me, doing analytics is mostly about getting some insights, mostly about learning something that is not obvious from your data set. If you take the example of the ad tech industry, imagine you have like a bunch of servers that are displaying your ads, and every time they serve one of your ads, they essentially log an event with a bunch of information related to the ad that you just served. So this kind of event could look like that. Now if I ask you to give me some insight about this event, you could probably tell me, okay, one of my ads has been viewed on NewYorkTimes.com by someone using an iPhone. This someone was located in Santa Maria, California, and his internet service provider was Verizon. So I would say, good job, you have been doing analytics because you are essentially able to understand your data sets of one event in this case. Now let's say I give you billions of these events a day, and I ask you the same question, you couldn't tell me that much about it because the scale is essentially too large, right? So doing analytics at scale is, being able to answer questions like, how many people in my network are using an iPhone? How many of my ads are viewed in NewYorkTimes.com? And be able to answer these kind of questions, even if you have to deal with a really large amount of data, essentially. So now, what does mean real-time in image advertising to 2008, which is a concept of overlaying ads on top of images. So we have image recognition technologies who are able to detect objects inside images. And according to what we can detect, we serve relevant ads on top of these images. So we have a very high viewability because people usually, when they browse websites, they focus first on images, so they see our images, ads first. In terms of number, we are processing 2.6 billion images a month. We're doing 10 million impressions a month, but we're actually producing 10 million events a day. We are working with 2,000 premier publishers and top advertisers like Coca-Cola, Cadillac, Disney. We are 132 right now. We are growing a lot. It's like a 40% year-over-year growth. We are growing a lot in terms of number of employees, but also we are seeing a huge increase in our data volume. So the people who are working at GumGum, they need to get some insights about the data we're producing. In this context of analytics. So when you talk about real-time analytics, there are essentially two main components. The first one is about response time. Like, how long do you have to wait every time you query your system to get an answer back? Is it seconds, is it minutes, hours, or even days? Obviously, when you talk about real time, you kind of have to put a definition about it, behind it, sorry. So you could have a different definition than mine, depends on the companies, depends on the use cases. At GumGum, we say that we are doing real time in terms of response time for our system, when we can achieve an average response time at around 1 second in our system, because we know the people we are working with, and we know they are happy about that, and we still feel like it's very fast, and we give them a nice user experience when they are exploring our data. So when you talk about real-time analytics, you also talk about data freshness. Like, how fresh is the data you can query on your system? What is the amount of time for an event to occur until it gets reflected in an answer in your system? So once again, you can have different definitions about real-time here. At GumGum, we say we're doing real-time in terms of data freshness when we can achieve an average latency ingestion of our events at around 30 seconds. Because once again, we know our people, we know that they're happy about it, and they still feel that the data is frequently updated, and they still feel like they're essentially understanding what's happening right now in our business. So, a little bit about me. My name is Guillaume. I'm French. I had my first experience in big data when I was working in Paris for a company called Hbase. I was doing image recognition in this company. So there was a lot of machine learning involved in this position, but not enough data to play with. So I decided to quit, and I joined GumGum 1.5 years ago. I've been involved in the Druid projects since the very beginning at GumGum, so I have about 1 year of experience now with Druid. A bit about GumGum. So we are an ad tech company. We have invented what we call